So it's Thursday morning, the day after the Killer's Gig, the final day of an exhausting Cisco Live conference, and you choose to join my session. That's terrific. Thanks for coming. You know what? I'm going to hang out for a few more minutes right after my presentation for those of you who want to ask questions live in person. But during the session, please make use of the WebEx app, and I follow up with each of you right after my talk. Very quick about myself. My name is Stefan Dörnberger. I'm out of Germany, and yeah, some of you might have picked that up from my accent already. I'm married, father of 3 wonderful kids, 18 years at Cisco, 25 years in the IT security industry, and I was lucky enough to get a graphics from the first Cisco user magazine called Packet I've ever read. I think that's a very much of a fun fact. What was the motivation for me to create this breakout session? I definitely wanted to better understand the signals of session cookie theft attacks, as well as how to map all this into the world of tokens, access tokens, refresh tokens, ID tokens. I'm going to talk about what is best practice in authentication, and also what's the status quo of mid-session control using shared signals framework. So how do attackers get into a company's network? Well, the initial access is the heavy lifting, right? Once they are in, they can make use of any tooling available to them. And initial access brokers, they sell these packages for just a few grand. So this example, it's a package. It comes with privileged credentials, with domain admin credentials. It also comes with an EDR EPP bypass mode tailored for Sentinel-1. And that helps the adversary to stay stealthy, undetected, once they are in. This one here is a slightly different offer. This guy sells a dumped database with thousands of records. And after I read it the first time, I asked myself, hey, Stefan, what would you ever do with 100,000 plus user records? I would definitely not test out each one by one manually, right? I would rather create a script, a tool that does this job for me, right? Now imagine you are a web service owner of your web service, and you definitely want to differentiate, to distinguish between real visitors of your web service and such an automated tool, right? Wouldn't you? And one of the most wideliest deployed and used methods for is reCAPTCHAs. We are all used to click on street lights, crosswalks, right? We are also used to listen to distorted voices asking us to solve a math problem. 4 plus 3, right? It's ridiculous. People dislike, and people also fail solving these reCAPTCHAs. I mean, this one here, this yellow thing in the middle, you barely recognize it as being a bus. Or this one, is the rear of the bike, is it really in this square? Yes, no, maybe, who knows? But here comes my favorite. Select all images with taxes. Select all images with taxes. I mean, where the heck do you spot a taxi? So people fail. People fail this protection layer. And, you know, full-stack bots powered by AI, even simulating human behavior, it's easy to solve this access protection layer, right? Now, before I continue, I want to make 3 things crystal clear. Number 1, please don't get offended me showing a computer game where you must fight back. You must harm your virtual enemies. It's a computer game. Number two, the game does not belong to Cisco. It belongs to third party, ID software, if I'm not entirely wrong. And number three, neither me nor Cisco glorify violence in any way. The reason why I'm going to show you this computer game, it has a scientific background. It is about how to make reCAPTCHAs more, resistant to these AI-powered bots. Question to the audience: who knows Doom, the computer game Doom, right? The first-person shooter game out of the 90s. There is a guy who came up with a fantastic idea to compile a minimal portion of Doom into WebAssembly and enabled communication between the game itself and the reCAPTCHA UI, the JavaScript CAPTCHA UI. It's fantastic. It's brilliant work. You know what? Let me show it you live. Let me switch from PowerPoint to the browser. So once you are in the game, you can actually enable permanent fire. And you must, you walk through this, world, and you must fight back. And if you are good enough and solve this reCAPTCHA, you are actually in. I lost. And you guys, you can enable this, reCAPTCHA into your web services and protection layer. Brilliant work, right? Now the problem is that these fraudster data centers, according to my research, mainly hosted these days in Indonesia and on the Philippines and Vietnam, they can easily solve this protection layer, right? So these reCAPTCHAs, they protect the login step, but not necessarily the session itself. Cookies, these tiny files, they are essential for the success of modern web applications, right? And I think it is fair to say that at the very first start of our conversation, I authenticate myself. You build out a session ID, you wrap it into a cookie, you send it to my browser, and then the browser continues to add this information in all subsequent packets for our ongoing conversation for the same session. Fairly easy stuff, right? Now, the irony is that these cookies, they are so extremely powerful these days, but getting access to them is way too easy. They get processed by UTM boxes, proxy logs, DAMs, operating systems, browsers. In the way how we, as the security industry, how we protect cookies is we set a lifetime. This is a terrible solution. And InfoStealer malware running on your system takes advantage of this reality. And if you think InfoStealer malware must be a huge blob of software, you are wrong. Just recently, the Threat Lab researchers from Varonis, they disclosed, they announced, a session cookie theft attack just by using a malicious browser extension. And I was lucky enough to catch up with one of these guys, researchers at last week's Identiverse conference in Las Vegas. It was pretty cool to have a talk with them, pretty intelligent guys. And the other tools taking advantage of those unprotected cookies are proxies. And most of these attacks, they start with a phishing attack. You get phished by mail. You get phished by, something gets sent to your social engine, to your social media, to your social media profile, right? And then these proxies, such as evil chinks, they become a full proxy, a relaying traffic between the tricked user and the real site. the user, they will click on a phish link, right? And then the proxy forwards and relays all the packets between the two parties. The phished user, they will enter primary credentials. Why? Well, they clicked on a link. And these primary credentials, they get sent to the real site, but before captured, intercepted, and stored for further use on the evil proxy system. Now, in case of an 2FA secured service, 2FA gets invoked, either by the web service itself or by the 2FA ecosystem. This part of the attack varies between the different proxies, even versions, but essentially what happens is that the phished user, it gets a 2FA prompt displayed, and they must solve a 2FA challenge, either accepting a vanilla push or even doing number matching. Now, this part is entirely bypassing the proxy, but it makes the real site super happy because it has seen a successful primary authentication as well as a successful 2FA. And of course, a session cookie gets built out and gets sent down to the client, but intercepted by the proxy. Now, Evil Jinx does a very interesting thing. It kicks the user back to any random site they want to kick you back, just to make you believe something went wrong or something timed out. But this gives enough time for the attacker to actually steal the session cookie and import it into their evil browser, impersonating you, adding additional 2FA methods to come back to the service whenever they want to come back. They can query critical Azure resources by using the Graph Explorer in case of a Microsoft targeted attack, or they can use PowerShell. Now, Evil Jinx is a very mature and very scalable proxy system. But to be frank, the community is quite active. And there are way more proxies around. And I agree, no VNC attacks, we know that they are not new. But you know what? Evil no VNC. It's a very well massaged and trained collection of techniques and frameworks. And it allows the attacker to run its browser in kiosk mode. Unlike Evil Jinx, Evil no VNC does not become a full relay, forwarding and relaying traffic, but instead, it actually tricks the user to directly control the adversary's browser through VNC. So no VNC, it is a JavaScript library with an application running on top, making this attack happen. Let me roll a video to show you all this live in action. On the right-hand side, you see the attacker's browser. On the left-hand side, the victim's browser. And underneath, terminal, I'm going to use to actually start the Evil no VNC server. I started with a parameter for the screen resolution I'm going to use to mirror and display the content of the real site through VNC to the victim once they come to my Evil no VNC service. And the second tab I'm going to use is, I just tailor a text file to see the incoming variables and even session cookies. Now, on the right-hand side, the attacker, they actually start Evil no VNC and connect that web browser to the real site. And this real site, again, that gets mirrored, displayed, and rendered with the screen resolution I defined once a new visitor arrives. So the tricked fooled user, they just click on this phish link. And once they click on this phish link, they directly control the adversary's browser in real time. The victim solves the primary credential challenge as well as every 2FA on behalf of the adversary. And once being signed in, I do see all the session cookies, session variables coming in. It also comes with with a key locker, so all input gets captured in this flat text file as well. Pretty amazing stuff. Now, how to get around, how stay away from these browser in the middle and adversary and proxy in the middle attacks? Well, don't get phished, right? Invest in a strong email security pipe. Invest in DNS and email security. You can think of top-notch policies in your PEP, in your enforcement point, taking care of location, but also taking care of trusted managed endpoints. But you can also stop this attack at the very first beginning during the authentication phase by using a phishing-resistant authentication method, such as passkeys. So on the right-hand side, you see the relying party. It's the service, the user attempt to sign in, Cisco.com, Google.com. In the middle, the user Sandra. She operates on her thick client and physically attached to this computer system by using USB, a security token, a roaming authenticator from Yubico. It comes with a fingerprint reader, a biometric element. Now, Sandra, she starts her day, she signs into the application, and this kickstarts a passkey registration, a passkey generation process. What happens is that a user ID gets created for the user Sandra, which is unique to Sandra, as well as unique for the relying party. The relying party, it sends a crypto challenge to Sandra's browser, including user information as well as the relying party. Now, the relying party, it is the domain the service is registered on, Cisco.com, Google.com. All this gets sent down to Sandra's browser, and the WebAuthn implementation in Sandra's browser does a very critical thing. It validates that the origin the relying party ID matches the origin the browser sees. And that ensures that Sandra builds out and creates passkeys for exactly this service. Right after that, the client-to-authenticator protocol is being used to actually create a passkey for this user on this relying party ID. Sandra, she must first decide where to store the passkey, in our case on the security token, and she must interact with the security token. And now the level of interaction heavily depends on the authentication flow, as well as the security requirements defined by the relying party, as well as the physical capabilities of the security token. In my case, Sandra, she just taps the Yubico key, a new passkey gets created, the private key securely stored on the authenticator. After that, an attestation message gets sent all the way back to the relying party, signed with an attestation private key that got burned into the token during the manufacturing process. And this message also includes the public key as well as the credential ID. Now, a credential ID, it uniquely identifies a passkey. All that gets sent to the relying party, and the relying party validates that incoming message. If everything looks good, the public key as well as the credential ID gets stored next to the user record of Sandra. And now Sandra, she can use the passkey for authentication. She signs into the service using her UPN. A challenge gets created, sent back to Sandra. It hashes client data. It does all that verification and validation and calls the authenticator for authentication. Now, the way how the authenticator choose the correct passkey Well, we are going to talk about this in a few slides. But essentially what happens, Sandra, she must interact with the authenticator. She taps, she holds her finger above this biometric fingerprint reader element, and a signed assertion signed with a private key gets sent back to the relying party. The relying party validates that signature with the public key it got stored during registration, and that finishes the authentication and registration ceremony of a passkey. Now, due to WebAuthn and all the underlying crypto, passkeys are phishing resistant, considered to be phishing resistant. But they are also pretty much immune against traditional replay attacks, right? As long as the relying party does not make a serious implementation mistake, such as reusing challenges or skipping verification and validation steps. So I actually run such a replay attack by using the burp suite. So the burp suite actually captures all the important HTTP conversation between my client, my browser, and a WebAuthn IO passkey test page maintained and owned by Cisco Duo. So all the communication gets captured. What I do first, I create a passkey. I register a passkey. And after the registration phase, we finish authentication. So that means I created a new passkey, and the private key is securely stored on the security token, on the Yubico key. Now, after the creation of the passkey, I actually can browse the HTTP history of Burp, and I'm actually interested in two requests. The one dealing with a challenge, and what I do with this packet, I just bring it to the repeater function, because I want to run a replay attack, right? And I'm also interested in a second request, the one that deals with client data, this one. I do exactly the same. I just bring it to the repeater function of Burp. Now, in the repeater function, I have two requests, one with a challenge and the second one dealing with client data. Now, let's rerun the first request. Let's just get a new challenge. No one stops me to ask WebAuthn IO to get a new challenge, right? And it happily serves a new challenge. Wonderful. Now, if I rerun the second request, the one that deals with client data, that's more interesting. In rerunning this second packet, I fail. It fails because the challenge does not match. But hey, I created a new challenge in the first packet. Why not copy over that newly created challenge into, the packet that deals with client data? And this is actually what I do. I copy that new created challenge. I mark client data and import that newly created challenge into the base64 decoded blob of this packet. So I cut or copy and paste the new created challenge in, and after I apply the change, I rerun the packet, and this time I fail again with a slightly different error message, but it essentially means I fail because the signature does not match. And as long as the attacker does not have access to the private key, which in fact they should never have, you could not effectively run such a traditional replay attack, right? So bottom line here is, the private key gets securely stored on the authenticator, and it never leaves the authenticator. Do you all agree? Really? Well, don't count me on the exact date. It was last year summer when Oikleak was reported, which is a side channel attack targeting the ECDSA implementation of an Infineon crypto library being used by Yubico Series 5 security tokens running software version below 5.7. I get it. Running such a side channel attack, it requires, bless you, it requires special knowledge, special hardware. You actually must have physical access to the token. You must drill in a tiny hole. But if all these prereqs are met, you can actually obtain a secret to create and forge new digital signatures. So if you are super worried about, by the way, Infineon, they updated the crypto library meanwhile, but if you are really skeptical and worried about oikleak and you still run Yubico version 5 or Series 5 below version 5.7, in all consequence, that means you must buy new tokens. Because to my knowledge, Yubico keys, you can't upgrade their software. So oikleak reminded me to upgrade my Nitro key. I personally work with Nitro keys. They are open source and headquartered in Germany. For me personally, an important attribute. And even not being affected by oikleak because they use a different crypto library, I thought it is a good praxis, a good practitioner to upgrade my Nitro key. And me as being a good security practitioner, I checked the version, I checked the upgrade path, I made sure that the security token is genuine. I did all these good steps. And I also check the passkeys being stored on this Nitro key. And believe me, I was very much perplexed once I did the list of the passkey when I've seen a number that was way lower than expected. So I missed some passkeys. And I had to do troubleshooting to better understand where my passkeys are. So I used WebAuthn.io again, and I created two passkeys. One, I gave it a name CL1, Cisco Live 1. It's a traditional passkey. I registered the passkey. I use it for authentication. Private key securely stored on the Nitro key. And after CL1, I created a second one. I gave it a name CL2 for Cisco Live 2. But in this case, I changed in the advanced settings a parameter. I created a non-discoverable credential. I registered this credential. I used it for authentication just to test that it works. And it essentially means both passkeys or both credentials that they are stored securely on my Nitro key. Now, flipping back to the CLI output of my Nitro key, after me providing the PIN, I see just a single passkey, the one for CL1. Where the heck is CL2? So obviously, there are two different credentials, type of credentials, discoverable as well as non-discoverable credentials. And for those of you with eagle eyes, you may have noticed that in the graphics for the security token, I actually used two keys. The red one indicates a passkey, the passkey how we understand and use passkeys. And the yellow one, it is known as the root key, another crypto key that gets burned into the security token during manufacturing process. Now, the difference between the two credentials is, again, the red one, this is a traditional passkey. The relying party ID as well as the authenticator during authentication, they have all the attributes they must know about. That gives you the best frictionless experience. But once a non-discoverable passkey gets created, this credential gets derived from the root key, pretty much calculated. And that allows the authenticator to store this derived key in a very, very compact form. So the difference between the two credentials is not only how the authenticator selects the private key during authentication, but also how efficiently they can be stored. With discoverable credentials, you can easily hit the capacity, the storage limit of an token. For example, my Nitro key, I can just store 50 of them. I get it. New Ubicos and the Google Titan keys, they can store way more. But with non-discoverable passkeys, or credentials, I have to say, you barely hit the storage limit of a security token. You can use, talking about storage, you can use your mobile as an authenticator. We all know that, right? On your Access device, Windows or Mac, such a QR code gets displayed, and then you scan this QR code, a passkey gets spelled out and securely stored at your authenticator, at your smartphone. Now, this process is known as hybrid authentication, formerly known as CABLE, Cloud-Assisted Bluetooth Low Energy. In the early phases of CTAP, the client-to-authenticator protocol, Bluetooth Low Energy was the only proximity validation method being supported. That changed, and it does not reflect the current situation anymore. That's the reason why the godfathers of CTAP, they renamed from CABLE, Cloud-Assisted Bluetooth Low Energy, to hybrid, and that makes perfectly sense. Have you ever asked yourself, what is the clear text output of such a QR code? I asked myself once, and you can decode these QR codes. There are online decoders. We know that, right? So the clear text output is this. It starts with FIDO, obviously the intent of this QR code, and then it follows that gigantic string of digits that can also be decoded. You must bring it into a byte sequence first, and then you can convert this byte sequence into a binary object representation, into a CBOR object. And after I did this conversion, I get this human readable output, and that's the human readable output for this wonderful QR code. And now you can study all these parameters, right? All these attributes. You read the 157 pages of CTAP to better understand. Why? Why should you do that, right? I had to do it once because I was in a situation where I was totally speechless. And it has to do with the value 2 of the attribute 2 of this wonderful QR code. It's a real story. I was back home in my home office, and I did service with an online application. I did a hybrid passkey or a hybrid authentication. So it worked wonderful being back home. The day after, I had to do business in a Cisco office in the Munich field lab. And the connectivity in my field environment, it looks slightly different. My Access device, my Windows device, was physically attached or cabled to the blue VLAN. My iOS device was layer 2 associated and layer 3 connected. And on both devices, hey, I could happily browse the internet, HTTP as well as HTTPS. Now, I tried to do the same hybrid passkey authentication, but this time it failed. The iOS device, it was stuck in the connecting phase, and I had absolutely no idea, no clue why. So I had to troubleshoot. And the first thing I did was I checked Bluetooth. But Bluetooth was turned on both devices. And proximity was given. They were literally laying next to each other. So Bluetooth was not the problem. And I had to learn and dig deeper. and I checked the front-end firewall, FTD appliance, and I immediately spotted a decryption policy. So I do that decrypt and re-sign with known keys with my Microsoft CA. And for decrypted traffic, I run access rules. One of them, for example, blocking a URL category called infrastructure and content delivery networks. That was not helpful at all. So I had to dig deeper. I had to read the access the access log, and I found the corresponding block, the block element. It indeed blocked my iOS device because of a decrypt action. And the root cause was the URL category infrastructure and content delivery networks. But the root cause was a URL I have never seen and read before. cable.auth.com, running on 17.188, yada, 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 known to be associated to Apple. So it had this awful taste of, yeah, that's the guy, right? That's why authentication doesn't work. And that was the reason why I did that decoding, because the attribute value 2 actually means I can use up to 2 tunnel server for hybrid authentication. What the heck is a tunnel server, right? I always thought that this authentication, it is a peer-to-peer Bluetooth magic communication, but it isn't. For hybrid authentication, you can use these 2 tunnel servers, and they form, some sort of web socket. And that is being used for authentication. And me, after getting rid of this block rule with the infrastructure and content delivery network URL category, I immediately saw a successful TLS 1.3 from my iOS device to 17.188, yada, yada, yada. So we all embrace passkeys, right? They make our life so much easier. But frankly speaking, even the best user experience is a bad one, in case I have to authenticate too often. Do you agree? I can just speak about myself, but guys, I have to authenticate way too often throughout a normal business day. And Federation, SSO, believe me, all of them are good protocols and techniques, but they do not solve the root cause, the problem. Especially not if a risk-based engine must deal with layer 3 attributes, such as IP addresses. Question to the audience: who knows Duo Desktop? Who knows Wi-Fi fingerprinting? Duo Desktop, it is a local application that can be installed on Windows, Mac, and Linux devices. The initial idea was to perform, device posture. But over the years, the software evolved, and the Wi-Fi fingerprint capability, this feature was brought baked into this Duo Desktop application. Now, what we know about Wi-Fi's, an access point, they send out SSIDs, which is the name of the wireless network, right? As well as BSSIDs, which is in fact the MAC address of the radio. And combining both attributes, well, it does not make an access point unique, but it makes it geographical specific. What Duo Desktop does, real time, during the authentication of your access device, it collects SSID and BSSID information. It uses a local salt. It salts the data. It hashes, and the pattern that gets hashed gets uploaded to Duo during authentication. What Duo then can do is it verifies that this Wi-Fi fingerprint matches a Wi-Fi fingerprint known to the user. If there is a match, easy, then Duo knows the user must be on the same place, or at least at the place where they already built trust. If there is no match, well, the user must have physically moved. Let me roll a video to show you all this live. A bit of a disclaimer before. It is a quite lengthy video, 5 minutes or so, and a bit complex in the sense of, please focus where the user physically is, okay? So the first thing I do is, in this video, I build trust. I sign into a Duo-protected application to build trust. Duo does all the good stuff it does. I use my key for authentication, and I'm signed in. I did that request, this action, out of Germany. Let's see what Duo knows about this action. It is a passwordless authenticated session sourcing from a Windows 10 device out of Germany. Okay, this is where my home office is. Now, I do exactly the same thing, but this time I start the browser with the web developer tools because, you know what? I set a cookie, a remembered device cookie during the first authentication. And as long as I have this device cookie, I do not have to build trust again, right? Best practice. I mean, this is good user experience. What Duo knows from this action is it is a verified session. I already built its trust from a Windows 10 device out of Germany. Cool. Now let's move. Let's use an overlay technology. Let's use a VPN to move, not physically, but from a layer 3 perspective to the Netherlands, to Amsterdam. I assign into the same service. I still have the cookie, but this time I must authenticate. I must perform a 2FA authentication. And this is embarrassing. This is embarrassing. This is really, really bad user experience. So what you will see on the video now is, I disconnect and come back from the Netherlands to Germany, to my home office. And what I do right now is I enable Duo Desktop to calculate the Wi-Fi fingerprint in my home office environment. After Duo Desktop is up and running, I perform the same action. I still do have the cookie. Nothing changed from that perspective. And I still do not have to do 2FA. The same as it was before, right? So let's see what Duo knows about this action. It is a verified session. But this time, coming from a Windows 11 device, I do get more device posture information due to the capabilities of a Duo Desktop. And I'm performing this action out of Germany. Good stuff. Now, let's move again. Let's use an overlay again, a VPN, and let's connect to California. After being connected, I perform the same action. I attempt to sign in, or I sign into this Duo protected application. I still do have the password, the device trust cookie, but this time I do not have to perform 2FA. This is really good user experience due to the fact that the Wi-Fi fingerprint was calculated and verified and validated with the known Wi-Fi fingerprints known to me as a user. Now, checking the access log of Duo, it's a verified session, essentially the same user in device risk, but this time out of the United States, Milpitas, California, San Jose. This is good stuff, but you know what? I'm a German engineer. Give me more data. And I used the ITDR, Cisco Identity Intelligence, to get the data I want to see. So I look up the user Stefan. I switch to the activity tab of this user to get all the details what I have done during the day. And I found that application portal. Look at this. This is event attributes and raw data. This is what I'm looking for, right? And scrolling down, I can see my Wi-Fi fingerprints. Look how beautiful they are. So, Wi-Fi fingerprinting, it adds significant value to the risk-based engine, to Duo's risk-based engine, and combined with layer 3 attributes, it helps Duo to efficiently step up or step down. So that wraps up the first half of the presentation. Let's switch gears a bit and let's move from session, cookies to tokens. I think it is fair to say that modern web applications, they make heavy use of APIs because APIs, they provide access to services, resources, data. And these API calls, they must be authorized. That's why we have OAuth. Question to the audience. Who knows Certainly, the tool Certainly? Anyone? Certainly was disclosed and revealed at last year's Black Hat conference. What Certainly does is it accepts incoming traffic, HTTPS, DNS, SMTPS, and IMAPS in typo squat and bit flip environments. What? We all know typo squatting. It is the process or the situation when your users mistype a domain. Instead of cisco.com, they enter tisco.com. Or instead of Google, Woogle, right? Now, the bit flipping, it is the same result, the same outcome, but bit flipping may occur due to faulty computer hardware, such as errors and glitches in computer memory. So what these two researchers, what they have done is they invented Certainly, and they registered a handful of domains. They are likely candidates for bit flipping on major services such as WordPress. So for example, they registered a domain called GordPress. And they associated these domains with a service, with their Certainly service, and let the system run over an extended period of time, I mean several months. Can you imagine how much noise they collected? But not only noise, they were able to capture meeting invites, they harvested passwords, cookies, but notably, shots, valid OAuth refresh tokens, and even bearers. So encryption, introspection, as well as token lifetime is of paramount importance. Now, there are several ways to learn OAuth and OpenIDC with a focus on tokens. Many people, they use these artificial playgrounds or simulation tools, debuggers. I'm not a huge fan of these tools, frankly speaking. I never learned anything useful out of these tools. Not because they are wrong, I just learn different. I'm a practical guy. I learn just different. That's the reason why I came up with a crazy idea to create my very own application. And I had to start with the bare minimum, with a base foundation. So I started with a client credential grant type in OAuth. A grant type, the best way I can explain it to you is the way how you get access to, or tokens generally speaking, how to get tokens. And the client credential type is very well built for a machine-to-machine communication. So very easy setup. A front end talks to a back end. So how this very minimalistic application works is the front end, it shares a client credential, similar to a secret if you want, with the Duo IDP. It validates and authorizes this, that credential, and in return, it serves access tokens. And now the front end can use this access token and share it with the calendar application, with the back-end service. And This was a huge learning step for me because I learned that OAuth is a delegated authorization protocol where no secrets get exchanged, but tokens over an HTTP endpoint. And OpenIDC is the authentication layer running on top of OAuth. If you have seen Sign Me In with X, Sign Me In with Facebook, that is OpenIDC, and in nearly all the cases, OAuth running underneath. So OpenIDC is the authentication layer. And some of you may ask now yourself, hey, why the heck not using SAML? Right? We are all used to security as search and markup language, and you are not wrong. By the way, you do not have to read anything on this wall of text here, but the point I want to make is both protocols, they share similarities. On the right-hand side, you have SAML, heavy structured XML documents. On the left-hand side, way more elegant OpenIDC. It is based on JSON Web Tokens, base64 encoded stuff. Now, again, both share similarities. Both protocols, they know about the issuer, if you want the IDP. They know about the subject, the person, the identity that needs to be authenticated. Both protocols, they deal with crypto, and both protocols also know about users' attributes. Now, OpenIDC is considered to be a bit lighter compared to SAML. And modern web developers, they definitely prefer OpenIDC over SAML. But there are two unbeatable advantages of OpenIDC. Number one, key management. The IDP generates in OpenIDC new keys, and it provides a JWKS endpoint. And then the client can fetch these newly created keys and can use them without any manual intervention. In SAML world, well, we have to deal with certificates, right? And we all know how much of a pain in the back it is to deal with certificates. And the other advantage is that OpenIDC provides granular access to resources based on scopes and claims, and depending on the relying party or the service, this can be used as an authorization attribute. So frankly speaking, I had a hard time to learn and understand OpenIDC. Not because the protocol is super complex, but I was not used to these new roles, personas, obligations, and all the stuff these personas have to do and must perform. And also, if you ask 5 different OpenIDC integrators, you get definitely 5 different best practices back, right? So I came up with an analogy that helped me to build my very own OpenIDC application with a focus on tokens. So imagine you are invited for a whiskey tasting event. You, the user, with a user agent. You show up at the club. Now, the first thing you must do is you must pass the security guy, the bouncer, acting as the relying party. Their job is to keep the door clean and safe. They let you only in if your name is found on the guest list. Ironically enough, they do not directly know if your name is on the guest list. They take your passport and they go to the club management. And then the manager, acting as the IDP, verifies your passport and cross-checks against the guest list. And if your name is found on the guest list, the manager also checks the date of birth. And if you are over 21, the club management, acting as the IDP, issues tokens and give these tokens back to the bouncer. Now, the bouncer opens the door for you and gives the resource server, the bartender, a thumbs up and you are ready to enjoy your first whiskey sour. And this is the outcome, the technical specs of this analogy. I'm going to use an authorization code grant type, a different grant type. The user hits first the application itself, the front-end application. It gets redirected to Duo for authentication, and then the front-end exchanges an authorization code, a code similar to a secret, if you want, with Duo, and then Duo happily issues, in my case, an access token, ID token, and a super optional but very helpful refresh token. And then these tokens, they can be exchanged with the backend, and depending on the claim and scope, I'm able and allowed to perform either a read-write or a read-only action, such as listing meetings or creating meetings. Let me roll the video for you. On the left-hand side, you see the HTML blob of this application. On the right-hand side, top, the front end, and below, the back-end service. Now, the first thing I do is I sign in. I log into this application. And what happens is, after me providing primary authentication, well, I get redirected by this 302 to Duo. That's why I have to perform user authentication. I build trust, user trust, device trust, all the good stuff Duo provides. And right after, the front-end application, it exchanges this authorization code with Duo. And in return, I get back tokens. This is not best practice. This is actually very vulnerable. Don't do this, right? I just display the tokens in the user agent because of the purpose of having them and showing them and doing stuff with them. It allows me to copy this ID token and decode it with an online decoder we all know about, .io. So I take this base64 decoded stuff, import it into .io, and this is now, the user attributes I get back. Now, cool. Let's work with the application. The first thing I do is I list meeting. I'm going to perform a read-only action. I want to list meetings. Once hitting this HTML endpoint, I have a meeting with Julie, as well as a reminder for Sandra's birthday. But the interesting stuff happens in the back end. An introspection endpoint at Duo gets called, and I get back a true. That means the access token being used for this action was valid. It's still a valid access token, and the scopes give me the privilege to perform this read-only action. Now let's create a meeting. A meeting with Tim, 10 a.m. morning. This is a read-write action, if you want. The same things apply to this read-write action. The meeting was successfully added, but the interesting stuff happens in the back end. Right? The same thing. I get back a true from the introspection endpoint. A 2 or 1 actually means an HTML object has been created. All that good stuff I get back from the scope, so I'm really allowed to perform this read-write action. Now let me sign out. Let me log out. We all know that invalidates access tokens, right? Now no one stops me to go to the list meetings HTML endpoint directly. And once I do list the meetings, the HTML tells me, hey, unable to fetch meetings. But the reason why is, well, the introspection endpoint response is a false. The access token is not valid anymore, and the 403 actually tells me, okay, I am not allowed to go further. POPs. Even the FBI is worried about token and session cookie theft attacks, right? But it seems that Google is working on a solution. And in fact, they have a very promising, well, it's not a prototype anymore. They have it in pre-prod, I would say. Server-side, you can test it. Server-side, you fetch code from a GitHub repo. And on the client side, on the browser, Google already released the DBSC, device-bound session credentials, to the Google Chrome browser since version 135. So you all have it enabled, or at least available in your browser environment. Now, the device-bound session credentials, or DBSC, the goal of DBSC are actually two goals. One, the browser should just receive short-lived cookies, but regular set cookies, but short-lived. And second, DBSC, it is a cryptographic proof that your session belongs to the originating device. Once being enabled on both ends, a public-private key pair gets created. The private key gets securely stored at the client. The public key gets stored and handed over to the server. And with this public-private key processing, the server can validate that the session belongs to the originating device. And with this simple concept, in theory, stolen cookies, they become useless to an attacker unless they also get access to the private key. Now, this is how it works. Both ends, the browser as well as the server, enable the DBSC. And what happens is that the server, it sends a registration information to the client, to the browser, where to register the keys, but also a challenge for the shot. Now, this starts a public-private key generation process at the client. The private key gets securely stored on the TPM of the Windows device. Windows is the only operating system supported while we speak. And the response message to the server is signed with a private key. It contains the public key, and that gets stored at the registration endpoint. Now, the response back from the server to the client is a 200. It serves short-lived cookies, as well as information how to keep up, how to maintain this session. And periodically, or frequently, I have to say, either initiated by the server or before the session cookies expire, initiated by the client, a refresh action is performed. And as long as the public key can be used to validate the signature, the server happily serves short-lived cookies. Pretty cool stuff. Now, wouldn't it be really great to see no cookies at all? But at the same time have the same secure device-bound security experience, as well as give your user a delightful authentication experience. That sounds way too good. Question to the audience: who knows Duo Passport? No one? So Duo Passport, it's the conceptual idea to share an authenticated session over or between applications. So you authenticate once for a Duo protected service using Chrome, and this auth information gets shared between other applications, such as a browser or even thick clients. And it means you do not have to perform another round of authentication. That's the concept of Duo Passport, and we have it available since, I think, a year or so, maybe even longer. Just recently, we disclosed the concept of a cookieless passport experience. So the same concept applies, but there is no session cookie anymore. Let me roll a video. Bit complex, but let me roll a video. So I first built trust. I, sign into a Duo, a protected application. Don't ask me why I use OTP here in this example. But anyway, after performing this authentication, I do get a cookie set. We all know that these cookies, they can't be shared. right? They can't be shared across or between applications. And even if I go incognito or into a private browsing window, if I sign into the same service, I must perform the same steps. 2FA authentication just for the sake that I also get a cookie. That is bad user experience, and we still work with cookies in this part of the video, and well, let's get rid of cookies. I enable Duo Passport to be able to share this authentication session, and in fact, I enable cookieless passport. So I perform the same steps. I sign in to a Duo protected application. I build trust. There is no cookie, well, different cookies, but not the auth session cookie anymore. And now me going into incognito mode of the same browser, going to either the same or a different application, I do not have to authenticate anymore. In fact, there is also no cookie being shared. In fact, there is no cookie available for you. So what Duo knows about this authentication experience is, well, it just tells you that it is a passport, a successful passport authentication. This is great, right? That's brilliant tech. Again, you build trust with the first application, and then that gets shared between applications. Question, wouldn't it be great if the first application would be your Windows sign-in you do in the morning? So this is what we do. With a great help of the Win Logon, Duo Win Logon software, which is a credential provider software. So we came up with the idea to, once users run through a registration or enrollment process, they won't see username and password in their Windows dialog anymore. Instead, they get pushed to their smartphone. The smartphone must be in BLE, in proximity to the access device. They finish, the push by just approving the push, and they must show biometrics. Once they perform this pretty much secure 2FA, this session, the first session, your Windows login gets shared between applications, such as browser, such as, for example, Chrome or even Chrome Incognito, Firefox, private browsing, private window, even between thick clients and applications such as WebEx, Cisco Secure Client, Outlook, to give the users this entire SSO experience. That's great. And let me roll a video how all that looks like. So what happens is, it goes very quick at the beginning. You boot Windows, and instead of a username password dialog, well, that's not existent anymore, you just get pushed. Bluetooth gets used to validate proximity. You approve the push, you show biometrics, that's it. Boom. You are booted into the user space. And now this first application is being used to share across applications, such as Chrome. I access or I sign into service number 1, no authentication. I go to the second application, no authentication. It's already done. If I move into incognito mode and use a different service, such as WebEx, no authentication required anymore. You already authenticated once, signing into Windows. Let's change application. Let's use a different one. Instead of Chrome, let's use Firefox. Guess what? No authentication required. You already authenticated, right? And even if we are going to use a thick client app such as Outlook, traditional AnyConnect or Cisco Secure Client, I have to say, or WebEx, authentication is already done. You do not need to perform authentication anymore. And again, there is no cookie being shared. Pretty cool stuff. So, imagine you are still in the bar. You finished your first whiskey sour, and you are about to order another one, a second one. And now imagine that the club management, the manager, got notified that your invite has been revoked. Transporting this analogy into tech, well, CAPE and shared signals framework, I'm going to explain in the next slide what it is. They take care of session or user session management in a zero-trust environment in a webhook style, so nearly real time. And that helps to adapt policies of PEPs, I mean enforcement points, and tailor these access policies due to contextual changes, such as the user risk has changed, or device posture has changed, or any other, literally any other contextual change you can think of. Now, what is SSF, Shared Signals Framework? It is a standardized way to exchange events between a sender and a receiver, right? It is an async publisher-subscriber model, and we all know these pub-sub models, right? PX Grid in ICE, one example. Lisp, to my knowledge, they also have pub-sub. Contact Center, Meraki. It's not a new idea. If you want, you can think about this stream getting created between a transmitter and a receiver, or a sender and a receiver. You can think about the OSI model, layer 4, that takes care of the transport between the entities. And if you want, think about UDP. Is it stateless? Well, that goes definitely way too much into an OSI discussion, but stateless in the sense of, I send you an event, and you can act on this event based on your capabilities. It has also a taste of TCP in it. Not for the data itself that gets exchanged, but for the stream itself. Such a stream can be short-lived, but also extremely long-lived, and you can transport a huge amount of data over such a stream. And CAPE, Continuous Access Evaluation Profile, it is actually a definition. It is a schema of use cases, zero-trust use cases, such as session revocation, a claim change, or even a contextual, a posture change on your system. So to summarize here, I like to call SSF as being the Autobahn. Right? The highway, the computer highway between a sender and a receiver. And CAPE are events that get transported over this Autobahn. Now, there is a company in this space. It's called Signal, SGNL.io. And the CEO of Signal is actually the godfather of CAPE, but he also has a chair in the working group of SSF. And they provide a for-free service where you can start playing and learning how to set up such a stream. So you register once, you receive an email, and sorry for that, technical challenges. You receive an email, you click on this link to get or to generate and download an access token. And with this access token, you can build your very own receiver. You download a collection for Postman, and then you add this access token into your first call. You get information about the stream itself. What Cape.io, what they provide a sender. So you have, with this simple call, a stream being enabled. Very, very easy. Now, what you can also do is you can send an event onto the Autobahn. Right? Depending on your type, the type of event you want to send, you add a few claim attributes and values, and once you are ready, you send it to the event queue. Me providing very quick an email here. Now, you can send this Cape event, and this gets sent to the event queue. Now, you can either poll, there's also a pushing event you can use, but in this particular case, I'm going to poll the queue to receive the data, the event I sent to the highway. And once I'm ready, I do get back this base64 encoded blob. Now, what I can use is, I can use Jot.io again to decode that base64 decoded blob. Now, let's copy it and use the online service and decode it. And after the decode, on the right-hand side, you see what I added as an event onto the Autobahn. So this is how I personally learned how to, start. I started learning about the streams and the capabilities of senders, receivers. By the way, a single entity can also be a transmitter, so sending and receiving at the same time. And this is what I use right now in a more, real-world scenario. Duo is able to handle Cape events. So we are part of the Autobahn, part of the SSF, Shared Signals Framework. And we partner with a company, an SSPM company called AppOmni. They do their job. They are pretty good in observing and monitoring major SaaS services such as Entra or Workday or Salesforce, I have to say, and other major players in the market. And once a session compromise has been detected by AppOmni, they send such an event onto the Autobahn. Cisco Duo receives this event with the aim to disconnect or kill the user session of the user being logged into Salesforce. Now, instead of going direct from Duo to Salesforce to perform this action, we actually send this event to Signal.io, and they have these customized APIs and all these scripts available for major players in this market. That's the reason why we contact Signal.io first, and then Signal instructs that session user termination for this user being logged into Salesforce. Let's roll a video how all that looks like. So I signed in first into a Duo protected application, an application portal and launcher application. I built trust using OTP. And I signed into, me as a user, Stefan, I signed into Salesforce. And I can do business with Salesforce, as we all know how it is. And what Duo knows about this session is, in the session details, Duo tells me, yeah, it is an active session, an ongoing session, and I already built it trust. It's a risk-based remember device, all the good stuff. Now, meanwhile, AppOmni detected a user session compromise. They detected that, hey, I'm a compromised user. Something is really going on with Stefan. And they send this event onto the computer highway, right? That's an SSF and Cape event. Now, in case I want to do now something on Salesforce, I get immediately disconnected. the session is killed. And what Duo knows about this is, yeah, it was a requested termination, a security alert sent by App Omni, and the action performed by Signal.io. Now that means if I want to do or continue doing business with Salesforce or other applications, I first must perform and sign in. I must build trust again, but this time with a step-up OTP. In this case, I must do number matching. We call it Duo verified push, where I must match, these 6 digits. And once I build trust again, I'm back in service and can continue working with Salesforce. Cool. Pretty good stuff. So what Duo knows about this one is, in the session details, it tells me again it's an active session, an ongoing session, and I build its trust with a verification code. So I build its trust using Duo verified push. Cool. So this wraps up my session. And I do not want to miss you going away without taking 3 practical key takeaways which are mapped to the session objectives. Many companies, they talk about phishing resistant, but in many cases, they actually mean tech. It's a good thing. But please invest, and this goes especially to the director, C-level guys here in the room, right? Please invest making users phishing resistant. Think about help desk. Think about these privileged identities and accounts such as admins. Help them. They need help. Invest in identity security, and don't forget machines, bots, chatbots, robots, non-human identities. I mean, they are literally everywhere. And the way how I start a conversation with my prospect customers, mainly in Europe, to be frank, I always say, think security not in tables. There is no such a thing anymore that I work on from 8 to 5 on a Windows device that is always patched and maintained in the same location on the same mainframe system. This is 80s, right? There is no such a single table anymore. We all have multiple identity or identity attributes, even accounts. We work on multiple operating systems, different devices, even BYOD. Some of them are patched in good shape, some of them are really, really bad. We use SaaS applications, on-prem applications. There is a huge dependency. And Cisco Identity Intelligence actually helps you to reveal these dependencies in your identity ecosystem. And why is it important? Because your friendly neighborhood adversary already thinks in graphs and not in tables. Okay, good. So please complete your session evaluation. It is extremely important to me, so it is for all the other speakers, right? If there was something you liked, please send it into the notes. If there is something where I could improve or can do better, please let me know. I follow up with each of you, okay? If you say, okay, I learned something out of Stefan's session and you liked it, hey, please give me a good score. A 5 doesn't hurt. And with that, I wish you all safe trip back home, and thank you very much for your attendance.